So this video is Integrated 2MA, Chapter 4, D-Day number 2. And for this, I'm going to write so ka toa. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So we always want to look and see the angle that we're at. From the 34 degrees, this is going to be opposite. This is going to be hypotenuse. So I am going to be using SOHCAHTOA. Okay. So I'm going to be doing sine of 34 degrees is equal to opposite over hypotenuse. I am going to multiply both sides by x. That's going to get rid of those. And I am going to get x sine 34 degrees is equal to 8. I'm going to divide both sides by sine of 34 degrees. And I'm going to do it in Desmos today to show you guys that we can do this in Desmos. Let's shut this down. So when we are doing this in Desmos, you want to make sure that you are in degrees. So if you come to this French right here, and if I come down here, I'm in radians, this is degrees. Okay. And so I want 8 divided by sine of 34 degrees. And I get 14 point, let's say 31. So 14.31 is our answer. Now on letter B, this one is Pythagorean theorem. So I am going to do 4 squared plus x squared equals 12 squared. So I get 16 plus x squared equals 144. So I am going to subtract 144 minus 16, and I get 128. So when I take the square root of that, I get the square root of 128. Now I can break that down. 128, let's see, divided by 4 is 32. So for sure let's see, I've got a 4, I think a 64 will go into this. So this is actually going to be the square root of a 64 times the square root of 2, which really means that this is 8 root 2. Okay, or if you're putting it in your calculator, and we're working this out. Let me just move this here. And I'm going to do the square root of a 128. The square root of a 128 is 11.37. If I do 8 square root of 2, you see that's the same thing. So 11.31 or 11.31 or 8 root 2 is the exact. On C, this is adjacent, this is hypotenuse. So we are adjacent hypotenuse, we're going to do cosine. Okay. So I'm going to do cosine of 49 degrees is equal to 7 over x. I am going to multiply both sides by x. Those are going to cancel out. And I am going to get x cosine of 49 degrees is equal to 7. So x is going to be 7 divided by cosine of 49 degrees. And when I put that into my calculator, So it was 7 divided by cosine 49. So 7 divided by cosine of 49. And I get a 10.669, so a 10.67. So this is going to be a 10.67. On letter D, from my 75 degrees, this is going to be hypotenuse. This is going to be adjacent. So that is going to be cosine. So I'm going to do cosine of 75 degrees is equal to adjacent over hypotenuse. I'm going to multiply both sides by 37. And I'm going to get 37 cosine of 75 degrees is equal to x, because those are going to cancel out. And when I put that into my calculator, so 37 cosine 75, 37 cosine of 75, sorry, 75. I end up with 9.576, so 9.58. So this is going to be 9.58. Okay, on our next one. So on the next one, if I am looking at 32 degrees, this is going to be opposite. This is going to be hypotenuse, so that's going to be sine of 32 degrees. Let me just rewrite that a little neater. So sine of 32 degrees is equal to opposite over hypotenuse. I'm going to multiply both sides by 62. And I'm going to get 62 sine 32 degrees is equal to x. So 62 sine of 32. When I put that into my calculator, I get a 32.85. So 854, so a 32.85. 32.85. On letter F, we want to find the angle. I know that this is opposite, this is adjacent. So this is going to be tangent of y is equal to opposite over adjacent. So to find my y, what I'm going to be doing is I am going to be taking tan inverse of 12/11. Should be less than 45 degrees because, or sorry, more than 45 degrees because this is greater than 1. So for tan inverse, if I go to functions, here's tan inverse, and I'm doing 12 divided by 11. I get a 47.489, so a 47.49 degrees. So 47.49 degrees is our answer. Okay, on number 2, what is the probability? So let me just fill this table out. So we're just going to be adding it. 1 plus 1 is 2. 1 plus 2 is 3, and so on. So let me just pause and add that in. Okay, so I filled out the table. What is the probability that the sum is 7? So for 7, I am going to get 1, 2, 3, 4, 5, 6. So 6 out of 36 or 1/6. What is the probability that the sum is odd or a number bigger than 10? Okay. So that it is odd, okay, would be all of these that I'm shading. Okay, so these are all odd numbers. And that should be half of them. That would be 18 out of 36. But it also had or a number greater than 10. So now I'm going to add on numbers that are greater than 10. So that's going to include 10, 10, 10, and 12. So now when I count, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. 22 out of 36 or 11 out of 18. What is the probability that the sum is odd and a number greater than 10? Okay, so odd and a number greater than 10. So that would be, this is an odd and greater than 10. So hold on. So that's really just going to be 11 and 11. So that's 2 out of 36 or 1/18. Okay. On the next one, we are going to be looking at a dice game involves rolling 2 dice. If you roll a 2, a 3, a 4, 6, 7, 10, 11, or 12, you win $5. If you roll a 5, 8, 9, you lose $20. Find the expected value. Okay. So let me do this. I'm going to circle the ones in orange that are a 2, 3, 4, 6, 7, 10, 11, 12. Okay. So let's see here. I'm actually going to shade it, probably be easier. Okay, so 2, 2, 3, 4, 6, 7, 3, 4, 6, 7, 4, 6, 7, 6, 7, 10. So 6, 7, 10, 11. So 7, 10, 11, 12. So if I count these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 out of 36. So there's 23 out of 36 ways to get $5 plus the others are the 5, 8, 9, 10, which would be the rest of that 36, which is going to be 13 out of 36. And in this case, we are losing $20. And so if I do this math, so I am going to do 23 over 36 times 5 plus 13 out of 36 times what am I doing? 13 out of 36 times, and I'm going to put in parentheses a negative 20. And I end up getting a negative $4.02, but the 7 is going to push it up to 403. And it is negative. So we are losing $4.03. Okay, per game. Now, if they ask if that's fair, it is fair if your expected value is 0, or if you had to pay that whatever you paid was the same as what you win. but in this case, it's not. Okay, on number 3, so we're going to be putting this in. So let me just get this. And here, I'm going to shrink this for a second. Okay. So I am going to, and you want to be careful. If I just go -2, and you can see it down at the bottom of my screen, raise the power 2, it is going to give us a -4, which is not the proper answer. So we want to be careful. We need to go parenthesis, -2, raised to the second power. That gives me a 4, minus 4 times -2 plus 4, and I end up with a 16. Okay, just move this slightly. Okay, so I can write, so that'll be a 16. I'm just going to change this to a -1 and a -1, so that's going to give me a 9. Change this to a 0 and a 0, and that's going to give me 4. 1, 1, that gives me a 1. 2, 2, that gives me a 0. 3, and 3, that gives me a 1. Okay, I'm having a feeling that the 4 is going to give me a 4 back. Yep, I see it's kind of symmetric here. And my 5, my guess would be it's going to give me a 9. And yes, it does. And then my 6, I'm guessing will give me a 16. And I got a 16. Okay. So then they want us to graph this. So I'm only going to plot what I can plot. So let's see. -2, it's not going to fit. -1, I'm going to get a 9. 0 is a 4. 1 is a 1. 0, sorry, 2 is a 0. 3 is a 1. Then a 4. Then a 9. And I'm going to connect this. Should be a U shape. Okay, now some things that they might ask us, they didn't ask us on this, but they could ask us for an x-intercept. And my x-intercept in this case is 2. A y-intercept. The y in this case is a 4. Down the row vertex, but we haven't really talked about that. Line of symmetry. And the line of symmetry is a line that goes through the center of this graph. And so that line of symmetry, would be right here at x equal 2. Okay. That would be our line of symmetry. So again, that is going to be at x equal 2. Okay, did not ask it on this question, but they do in general. Just gonna make this a little smaller. Okay. Actually, and they did ask us for a vertex down here. Vertex is the one point that doesn't have a match. That vertex is going to be right here, that point right there, which is going to be 2, 0. Happen to be actually our x-intercept. That's not always the case. but you do need to give it to me as a point, 2, 0. That is our vertex. Okay, on number 4. So on number 4, this angle here and this angle here would be the same. So what that means is my 3x plus 1 along with my 5x minus 5 together is going to make 180. And so I'm going to get 8x minus 4 equals 180. I get 8x is equal to 184. I divide by 8. So 180 divided by 8, I end up with a 22.5 for my answer. Let's see. Oh, sorry, it was not a 180. It was a 184 divided by, 184 divided by 8. Sorry, just 23. So that actually was a nice number. It's a 23. On B, when we have an equilateral triangle, then this side here, that 3x plus 5, if I double it, it's going to be the same as the 7x minus 2. So together, the 6x plus 10, which either I double or I add with itself, has to equal 7x minus 2. I am going to minus 6x from both sides and add a 2, and I get x is equal to 12. And that's what they wanted, was for us to find our x. On letter C, this, because of parallel lines cut by a transversal, those are both going to be 61. Then also what I know is if I take this one and this one, these remote interior angles, they are going to equal the exterior angle. So I am going to take 102 minus 61, and I get 41 for my answer. Okay, on number 5, we're going to do a flow chart. So first thing I'm going to say, angle G is congruent to angle G, reflexive. Then I am going to say that line segment IA is parallel to NT, given. And that's going to lead to me saying angle GIA is congruent to angle N because of corresponding angles. And when I have this angle and these angles here, I can say that triangle GIA is similar to triangle GNT. And my reason is going to be angle similarity. And then I'm going to do proportions, and I have to be careful. When I do this, this 5 is going to go with the whole entire side. So I'm going to say 5 over 5 plus x is equal to 9 over 16. And I'm going to get 45 plus 9x is equal to, and I'm doing, let's see, 16 times 5, and I get 80. So I'm going to get 9x is equal to And I'm going to do 80 minus 45, and I get 9x is equal to 35. So x is equal to 35 over 9. And I can leave it like that or give it as a 3.8 repeating. On number 6, you're putting up a tent. The center of the hole holds up a 10 that's 10 feet tall. Just get a triangle. Oops. And so holds up a tent that is 10 feet tall. The angle that it forms with the ground is 58 degrees. Find out the length of the cable, so I want that. So that is going to be opposite and hypotenuse, so that's going to be sine. So we're going to go sine of 58 degrees is equal to opposite over hypotenuse. I'm going to multiply both sides by x, and I'm going to get x sine of 58 degrees is equal to 10. So x is going to be 10 divided by sine of 58 degrees. And when I put that in my calculator, 10 divided by sine of 58 degrees, I ended up getting an 11.79. So x is going to equal 11.79 feet. On number 7, expected value, and we want to know if this is fair. So this is going to be 1/4. This is 60 out of 360, which is going to be 1 out of 6. And let me just think of it this way. This is going to be 90 out of 360. So I'm going to take 360 basically minus 150 and end up with 210. So this is going to be 210 out of 360. And if we want to reduce that, that's 21. Let me just move this. That's going to be 21 over 36. And if I divide by 3, that's going to be 7 over 12. So I am going to take -8 times 1/4 plus 7 times 1/6 plus 5 times 7/12 and put that into my calculator. So let's see, -8 times 1/4 plus 7 times 1/6 plus 5 times 7/12. And I end up getting $2.08. So this is going to be equal to $2.08. And they ask if this is fair. This is not a fair game because expected value is not 0. So not a fair game. And again, it's because the expected value was not 0. Factoring. Okay, so the first thing you always want to do is look and see, can you factor something out of everything? And I cannot. Then you want to kind of look and see, hey, maybe it's one of these special ones. So I notice that there's a square in the front and square in the back. So maybe it is a perfect square trinomial. So if I take the square root of 49x squared, it's a 7x minus. I take the square root of a 25y squared, that's a 5y. Quantity squared. Now I check by multiplying this together and I get a -35xy. And if I double that, I get my negative 70xy. That means it was a perfect square trinomial, and that's my answer. On B, what I notice is that I can take an x from each of them, but then I have a 12 and a 27. I believe I can take a 3. And like I said, an x. And I'm going to get a 4x squared minus 9. Now, we always factor completely. So this 4x squared minus 9 is actually factorable. It is a difference of 2 squares. So I'm going to take the square root of 4x squared, which is a 2x. I'm going to take the square root of a 9, which is a 3. So I'm going to have a plus 3 and a minus 3. And you have to have that 3x out in front. On letter C. It looks like I can take a 4 out of everything. Let me just double check. And yeah, I can take a 4 from it. So a 4, and I'll be left with an x squared minus 3x minus 28. And then this is going to be a diamond. Okay, when I say this, I mean, oops. This is going to be a diamond. So what multiplies to a negative 28 and adds to a negative 3? That's going to be a negative 7 and a positive 4. So this is going to be an x minus 7 and an x plus 4. And again, don't forget that 4 out in front. On D, I'm going to factor out a 6 and an x, and I'll be left with x squared minus 3x plus 2. And again, I'm going to have a diamond. What multiplies to 2 and adds to negative 3? That's going to be a negative 2 and a negative 1. So I'm going to have 6x times x minus 2 times x minus 1. On E, difference of 2 squares. Square root of 36x squared is a 6x plus, and the square root of a 25 is a 5. So one's going to be a plus 5, one's going to be a minus 5. Again, difference of 2 squares. For this one, it looks like I can take 4 from everything, and I get an x squared plus 6x plus 9, and then x squared plus 6x plus 9. That is a perfect square trinomial, so that's going to be an x plus 3 squared. So 4 times x plus 3 squared. Okay, on 9. So what I'm going to do is I am going to just check the last number each time. Okay, so what I'm going to do in the first one is I'm going to be basically using the triangle inequality. So if I subtract these, I get a 1. If I add them, I get a 9. And 8 has to be in between those. So this one's acceptable. And again, I should write out officially because 1 less than, try it again, trying to color code. 1 less than 8 less than 9. So that's going to be okay. Now for the next one, I'm going to take 8 minus 1, which is 7, 8 plus 1, which is 9. That's not going to be the case because my 12 needs to be in between those, and it's not. And my last one, if I take 10 minus 7, I get 3, and 10 plus 7, I get a 17. This is not because 3 and 17, 2 is not in between. So in this case, it's only 1. On 10, I have parallel lines cut by transversal, and I have these alternate interior angles. I also have these vertical angles. And I do have another set that would also be alternate interior angles. So I'm just going to color code so you can see what goes with what. So basically, this X and this 9 are going to be matching in terms of being corresponding to each other. And then the 9, which is in between my blue and orange, is going to match with this. So when I set up my proportion, I can say X over 9 is equal to, let me just rewrite that. X over 9 is equal to, and I'm talking right now, this X and this 9. So I am going to say 9 over 18. And when I cross multiply, I get 8x is equal to 81. And when I take 81 divided by 18, I end up with a 4.5 for my answer. And that's the end of this video.